Take a deep breath. That atmosphere you're breathing, it's unique in the solar system. None of the other planets orbiting our sun have anything close to it, but it might not have always been that way. Hello, I'm Nancy Neal-Jones from the Goddard Space Flight Center in Greenbelt, Maryland.
And I'm Gary Napier from Lockheed Martin Space Systems in Littleton, Colorado. Now take another deep breath, because humanity's latest interplanetary probe called MAVEN is under an hour away from arriving at Mars. It's an exciting time for science.
Now, football games may have dominated millions of viewing schedules today, but here at the MAVEN Control Center, the focus has all been about throwing a long pass, 442 million miles, one planet to another. Tonight, we're here to see Mars make the catch, so to speak, as MAVEN enters orbit.
That's right, Nancy. We're in the center of the action this evening, coming to you live from the Mission Support Area here at Lockheed Martin's facility in Littleton, as flight engineers and project scientists prepare for MAVEN to enter Martian orbit. It's a little after 7:30 Mountain Time right now, 9:30 on the East Coast, 6:30 on the West Coast, but 138 million miles away, it's showtime. And there's a lot to talk about tonight, from the scientific value of the MAVEN mission to how the spacecraft works to the big picture behind NASA's overall Mars initiative. For all of you watching the events tonight on the internet, we've got great social media presence running around the internet. Here on the screen, you're going to see the primary Twitter and hashtag Journey to Mars and hashtag MAVEN. So log in, join the conversation with us.
It's rare when humanity sends a probe to another planet, the result of many people working hard to achieve something that simply could not have been done alone. MAVEN is the name of a mission as well as a spacecraft. It stands for Mars Atmosphere and Volatile Evolution. The N in the word MAVEN comes from the last letter of the word evolution, in case you're closely following the etymology. MAVEN is all about discovering how the Martian atmosphere evolved. Understand a planet's atmosphere, and you begin to understand that planet's history.
We know that our own planet underwent dramatic changes that evolved from a primitive rock into a vibrant place that it is today. Mars did too. But how it changed and why are profoundly different from what happened in our own world. In its early days, Earth became a water planet and stayed that way, even as the atmospheric chemistry changed. Scientists have plenty of evidence that Mars also was wet long ago with a thicker atmosphere, but it still holds many mysteries. Mars is now dry, cold. The fact is simply we just don't understand what caused our neighboring planet to change so dramatically. MAVEN is part of a NASA-wide initiative to find out.
It takes a lot of planning to pack a science lab for a busy expedition and ship it across the solar system. MAVEN is no exception. We have a great lineup of guests tonight to help explain and illuminate the whole MAVEN mission, from the overall big picture to simply getting to Mars, to the extraordinary research the science team will conduct. So first, let's start with an overview of the mission to help you get into a MAVEN frame of mind.
The MAVEN spacecraft's been traveling for 10 months since it blasted off from Cape Canaveral on a United Launch Alliance Atlas V rocket last November 15th. Tonight marks the arrival of its ultimate destination, taking up residence around Mars and preparing to start work gathering vital scientific data about the red planet. Before we hear a mission status update, let's take a quick look at the final ground-shaking event that sent MAVEN on its journey, the launch.
Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, main engine start, ignition, and liftoff of the Atlas V with MAVEN, looking for clues about the evolution of Mars through its atmosphere.
So joining us now is a very busy David Mitchell, project manager for MAVEN. He's with the NASA Goddard Space Flight Center, and so I guess that kind of makes you the MAVEN, right, Dave? Thanks so much for joining us.
Sure, it's a pleasure to be here.
Hey, so it's been almost a year since liftoff. So, I mean, can you tell us, are you a little more excited when it lifted off down at Florida, or now that it's arriving at Mars tonight?
Well, it's interesting. It's a lot like the same kind of feeling because it's really, once that first stage lights on the Atlas, it's away, and in this case, it's the Mars orbit insertion. So really, the only difference I feel, I mean, the butterflies are there and everything, but with a launch, you don't know if it's going to launch on that day because of weather or technical, but this is a one-time event with Mars orbit insertion.
It's coming in tonight no matter what.
Absolutely, no matter what.
So give us an overall sense of where we are in the mission right now.
Sure. All the commands are on board. Okay. It's on its own, operating autonomously at this point. Okay. We're about to slew the spacecraft. And in just a few minutes, we're slowing the spacecraft to turn it in the direction that will be basically braking. We'll be slowing down with the rocket engines. And so about 50 minutes after the hour, we'll fire the rocket engines. So big event in just about 10 minutes or so coming. But everything so far has been perfect, on the money at this point. Trajectory shows that we're right on the money. So really, we feel good about the system, we feel good about the team, and the track it's on right now. So big moment in about 10 minutes.
Good to hear. So, I mean, so your team has been evaluating the status over the whole cruise. So we just heard kind of the status right now. What about that 10-month cruise? How was it through that time?
Right. So we checked out all the spacecraft subsystems. We checked out all the payloads. So the scientific instruments and the telecom relay, and everything checked out great. So everything's all set for the Mars orbit insertion. So we feel good about it. 60 days ago or so, we turned off all the instruments to be in a quiet mode as we approach Mars, and we'll turn them on rather quickly after we get there.
So we know that Mars is kind of tugging on MAVEN right now.
Right.
Just how fast is MAVEN traveling relative to
Mars?
So
it's been picking up speed actually in the last hour quite a bit. I mean, in the last few hours, it's almost doubled its velocity. So right now, as we approach, in the next few minutes, it'll be going about 12,800 miles per hour. And then when we turn on the rocket engines, we'll slow down to about 10,000 miles per hour. So still a pretty good clip there.
So during that 10-month cruise, I mean, was the spacecraft kind of in a hibernation state, or were you guys really doing some scientific research?
Yeah, it was interesting. We took the opportunity as we're sailing from Earth to Mars to actually, well, we turned on instruments, but we also calibrated them. And we had an opportunity to measure solar winds between Earth and Mars, and also a distant view of Mars with an ultraviolet spectrometer. So we've already got our first glimpse of Mars.
Wow. So just real quick, I mean, we're talking about long distances here. What sort of effect does that have on communication?
Right. So at this point, Earth and Mars are about 138 million miles apart. And so what that means is that kind of distance, it takes signals from our MAVEN spacecraft and from Earth, both ways. It takes one way, it takes about 12.5 minutes for the signal to get there.
One-way light time.
So in fact, when we fire these engines, they'll have fired 12.5 minutes before we see the first ignition. And again, that's happening in a few minutes now.
Awesome. Fantastic.
So I better step away. But
well, good luck to you and the whole MAVEN family.
Thanks
I know it's a fantastic night, long working there.
All right.
Best of luck to you.
All right.
We're going to be standing by as we prepare for the main engine to fire on the MAVEN spacecraft in just a few minutes. What you see is a real-time simulation of the spacecraft in flight. It depicts the spacecraft on approach to Mars just before the 6 engines ignite. We'll be checking in on flight status all the way into orbit. As we've just heard from David Mitchell, there's a lot involved with getting from one planet to another.
You know, Nancy, I think Han Solo once had some wisdom about this, but he was talking about the challenges of traveling through hyperspace.
Well, considering that Han Solo is busy doing other things right now, you could say the same for the travel around our own solar system. Right. MAVEN has a flight team paying close attention to everything that's happening right now as it quickly approaches Mars.
In Pasadena, California, the Jet Propulsion Laboratory is also in the loop with the navigation team. They're watching vital data about the flight's trajectory toward the planet. But the main action's taking place right here, just a few feet from us around the corner where we're standing in the mission support area back here in Littleton. MAVEN's mission control.
It's here that the principal investigator, Bruce Jakowski, the project manager, David Mitchell, and the flight crew are working to ensure MAVEN's successful insertion into orbit. As we move around the room here, we see a number of workstations where engineers are monitoring data and real-time operations.
So, joining us now is Tim Preiser. He is the, come on to the stage here, Tim. How are you
Hi,
tonight?
Gary.
Tim Preiser is the Chief Spacecraft Systems Engineer here at Lockheed Martin. So, Tim, we're just a few minutes in front of the maneuver. I mean, how are things going?
Everything is nominal. It's a boring word, but it's a fantastic word in my mind. No issues are being worked, no concerns at the flight team level. The spacecraft is
I'll tell you
flawless.
what, why don't we walk over to the MSA? Let's take
Yeah.
the viewers over there and kind of let them get a little bit of an eye, and you can give us a bit of a tour of what's going on. So, in general, tell us about this MSA in whole. What other spacecraft are here?
So this spacecraft shares an MSA with Juno on its way to Jupiter. Odyssey and MRO are already at Mars. The spacecraft team over here has emulated, simulated, and tested this event so many times now that they have a very detailed checklist of what they should expect to see tonight, what they actually could expect to see tonight, and if they, depending on which one it is, should versus could, they're already starting to prepare for the appropriate actions as the events unfold.
So we're going to let the camera move in. I think we need to stay a little quiet here. We're right on the edge of the flight team there. They're looking pretty busy, pretty intense. Kind of talk to us about some of the different subsystem areas.
All right, so the telecom subsystem, which is what we'll see first, they're watching for the signals of the telemetry from the spacecraft. And across from them is the propulsion subsystem that's watching the pressurant start to go down as the burn begins. In the middle, the guidance and the controls guys. Since we're in this attitude hold prior to the burn, they're watching the attitudes and the attitude rates. And on the far side is the navigation team and the flight software, and specifically the fault protection engineers, watching for any error counters to start to show up.
A lot of watching going on right now, so it's kind of a little bit of a roller coaster at times.
Yeah, but you can see they're calm, they're cool, and they're very confident right now. Like I said, they have done this event so many times. Tonight is going to be very surreal.
Very good. I'll tell you what, we've got a lot of NASA social folks.
Base, go ahead. Nav can confirm that the SLU has finished. Base copies, thank you, sir.
So we just heard that the SLU has completed. So now we're ready, we're lined up, and now it's just a matter of time until it's time to ignite those engines.
Fantastic, that was real time. I'm going to let it run here for a minute.
Okay.
Let's just listen in a little bit more and see if we can hear what the flight team's talking about.
And like I said, each individual has their subsystem specific checklist that they're going through. Telecom is looking at the signal strength. The propulsion engineers are making sure that the pressurant is where it needs to be, where they expected it to be. The guidance and controls guys are watching the attitudes and the attitude rates. Spacecraft is very quiescent at this point.
I think they've kind of gone quiet right now. I know we need to toss it over to another segment. What we know is going on is all around the country and even around the world. The social media activity around MAVEN has just been very exciting. We even have a local NASA social group here in Denver. Earlier we asked them to submit a lot of questions to us, and we asked this flight team if they could help us answer them. And so let's take a look at what some of the questions and answers we had with the NASA social.
Copy. Thank you. Again.
Welcome back. This is special live coverage of the MAVEN spacecraft's dramatic arrival at Mars. I'm Nancy Neal-Jones.
And I'm Gary Napier, and we're joined still by Tim Preiser. He's our from the project MAVEN team here at in Littleton. He's going to help us translate some of the real-time operations for us.
Sure. During this event, the data rates are so low that really the only thing we have is the signal from the spacecraft that the radio generates, and then the navigation team knows what that frequency should be, but because the spacecraft is moving, we get a Doppler effect. The navigation team is able to measure that Doppler effect, and that is going to be the keynote speaker tonight. Not only the subsystem engineers that are concerned about their specific subsystem, but the navigation engineers, all of us will be watching that Doppler plot tonight because that's the most direct information that we're going to have. The spacecraft at the moment has completed its slew to the burn vector and is waiting for this flight software to command the engines to start.
How long are those engines supposed to fire? Is this a long event, or are they just for a short period? I mean, just kind of give us an idea of what's expected.
It's about a half an hour. 33 minutes is what is expected, but from my perspective, that is going to be a very long 33 minutes, yes.
So what if the, I mean, right now I'm looking here and it says time to burn start. Is that accurate? That's saying about 3 minutes, 50 seconds we've
Yes,
got still.
That's why my knees are moving right now. I'm getting excited, and I think we all will in just a few moments. But as I said, the spacecraft, she's ready. She's been ready. She's been committed. There's 12 minutes of light time between us and her. So we can't reach out and give her a helping hand any longer. We're 3 minutes from the start of the burn, and it takes us 12 minutes just to talk to her.
So just explain that just for our viewers. We all know what light years are, and these are light minutes. What does that mean? It's 12 and a half minutes of light time delay.
Correct. So it's the time that light takes to travel, over that duration. So actually, it's a very long distance, but we're talking 140 million miles between the three of us and MAVEN. So she's committed. For instance, when the farmer puts bacon and eggs on the menu for the next morning, the chicken has a vested interest, but the pig is committed. She's committed. There's no turning back now.
So it takes a radio signal traveling at the speed of light, takes 12 minutes to go from Earth,
Yes.
ground control, all the way out to the spacecraft. Spacecraft does something with that signal, 12 and a half minutes back. So what I'm hearing is this isn't something that happened with a joystick. This isn't something that the flight controller we just saw are hitting a button. What's on board that's keeping that this thing knows to go off and do its thing by itself?
Correct. There's no joystick. The subsystem engineers have orchestrated this event over the last 2 years, but the last 10 months they've perfected it, they've tested it, they've run it on the spacecraft, they've run it on the simulators, and everything is, like I said, 902 unique parts on that spacecraft need to operate at the right time in the right manner for this to be successful. And that sequence of events is on board, and the flight software is going through the checklist. And that's what we're watching. And within 2 minutes...
Yeah, there we go. So we can see we've got about 1 minute, 50 seconds.
Now,
this is pretty accurate, right? We know when the engines are going to fire.
Right.
We don't necessarily know when they're going to turn off.
Right. So the start time is very deterministic. I mean, that is the one thing that the spacecraft team was able to tell MAVEN and the rest of us is going to happen at a very precise moment. The end of the burn, and we'll go through that when we see the Doppler plot that everyone will be so interested in a moment. The end of the burn will be dictated by the accumulated velocity so far. And the accelerometers on board are measuring as we go. They've been given us a magic number. When you reach this number, put your hand up and say we're done, and the flight software will cut off the engines.
What's going through the minds of the folks in the MSA right now?
Well, like I said, they're steely-eyed spacecraft guys. They are calm, they're cool, they're collected. They've watched this event so many times. They're going through their mental checklists of what should be happening. And as the telemetry comes down, they could get this comforting confirmation of, hey, it is happening the way it should. But at the same time, they're watching what could happen, because they've all thought through that as well. And they're preparing themselves in either case, should happen, could happen, to take the appropriate action as the events unfold. We're within 30 seconds, so.
We're getting there. So how are you feeling?
I can't contain myself any longer. We're going to watch the magic, the technological wizardry that teams like this routinely perform. It's just staggering to me.
Now, this is a simulation, clearly. I mean, but you know, there's no cameras flying by next to MAVEN,
That's
so
correct.
we're simulating, but it's based on real telemetry information and fact.
Getting close.
Yes, this simulation is following the same timeline that's on board.
Oh,
Oh,
So if you were on board, or if you were traveling next to MAVEN, you would see the engines have just started.
so so the mission clock is saying, are we in the deceleration burn? What's going on?
We are, the burn has started. So 33 minutes plus or minus from now, the burn will be complete and we will be captured. We will have transitioned from a heliocentric orbit to a Mars captured orbit.
very good. I don't know if we can be able to pull up this Doppler chart, but can you explain what's going on? We've got this Doppler chart.
Right,
Here we
right.
go. Tell us what's going on. I assume this is right there where we are in time.
Correct. So hopefully the folks that have joined us tonight can see this. You know, the burn has started, and that is this green set of dots.
And I don't know if the listeners can hear that. A lot of clapping on. I know we've got the cameras fixed over there. There's some good clapping, and I think they're telling us.
What we're seeing, right, real time, this dashed line is time now through the burn. So you'll see it march across. The green dots are, and let me just explain, green we use, there are 3 deep space network stations on Earth. There's one in Goldstone, California. It's green, so that's the one that's making these measurements now. There's also, we have friends in Canberra, Australia that have been taking measurements for us all the way through. And they're in Madrid, Spain, have been helping. So when they do the station handovers, these colors will change from green to red to blue. But the ones we're watching right now are these green dots. Each
Okay.
dot is a measurement
Thank you.
from Goldstone.
Okay.
And as these dots come in, if they follow this set of dots that have been laid out in front of it as the happy path, I'll call it, that is as theoretical perfect as you can achieve. The navigators know, because of the frequency that the radio on board has, because the spacecraft is moving, that signal encounters a Doppler shift. So the navigators know what that frequency is at the radio. They can measure the Doppler shift, and with that information and some math, this is where science, technology, engineering, and math come together to solve a problem that's very difficult to comprehend. They can take that Doppler shift and they can measure and derive the velocity and be able to track the burn. And if we track right down the middle, then everything is nominal.
Okay. So in the middle is nominal. They have to stay within this.
These lines describe what could happen if all of the uncertainties and performance excursions start to stack up. You know, we have 6 engines. They were all built alike, but just like 6 children, they don't all behave alike.
Right.
So if you stay between these lines, these are still the expected performance dispersions that we'll see tonight.
Excellent. That's great. That's really good. This is exciting stuff. Have you worked on a number of Mars missions?
I have, but it never gets old.
Never gets old, I'm sure. So Tim, don't go too far. We're going to have lots more questions for you this evening as MAVEN maneuvers into Martian orbit.
Thank you.
That's you. That's you, Nancy. So as the spacecraft's getting closer to achieving orbit around Mars, it's important to remember why this effort is so important. Humanity has long pondered about the character of our sibling planet. Because of its similarities to Earth, Mars has always provoked special interest. What's more, we're not the only show that's happening at Mars this week. Just 3 days from now, an Indian spacecraft called MAVEN, the first for that country, is about to reach Mars for scientific investigations of its own. Everyone at NASA and its partners wishes that team all the best, and especially the MAVEN team tonight. These folks really are the ones that knows what's going through their Indian counterparts' heads right now. They know what they're going through. MAVEN is all about exploration, and exploration in this case means science. There's nothing in the solar system, or anywhere else for that matter, that exists without being influenced by other objects, and Mars is no exception. Questions about what happened to the Martian atmosphere lead scientists to important questions about how the sun played a role. We're going to spend some time discussing the number of compelling scientific mysteries and how the MAVEN team intends to pursue those answers. But let's start with an overview of the central question. Why was the sun's influence so profoundly different on Mars than on Earth? Here's a closer look.
minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Main engine start, ignition, and liftoff of the Atlas V with MAVEN, looking for clues about the evolution of Mars through its atmosphere.
As we get closer to the red planet, we near the end of MAVEN's prologue. The real story begins once the spacecraft begins taking measurements of the Martian atmosphere. Here to talk about the mission's primary science goals is co-investigator from the Boston University, Dr. John Clark. Welcome to the program.
Thank you, Nancy.
When most of us think of interplanetary science missions, we imagine rovers crawling around or flybys of gas giants with high-resolution cameras. Can you explain to us MAVEN's primary science goals?
Yeah, MAVEN is a little different from that. MAVEN is a global climate change mission for the planet Mars. It will study the atmosphere of Mars and how that may be escaping today. And by learning the processes by which that happens today, we hope to extrapolate back in time and learn about the history of Mars.
So, what are the main things that the MAVEN science team wants to examine as it begins its investigations?
Well, there are a number of things, but we have a set of instruments that are designed to measure the neutral atoms and molecules in the atmosphere of Mars, how those are escaping today, including H and O, so it tells us about the history of water on Mars. And then we have instruments that will measure ions and electrons, and that will study the interaction of the solar wind with the atmosphere.
Well, Earth's magnetic field protects us from solar radiation, but I gather Mars doesn't have anything like Earth's protective magnetic bubble. Does that play a role?
Yeah, that's very important. Right now, the solar wind, the atmosphere of the sun, blows directly into the atmosphere of Mars. And that process, that interaction, can strip away much of Mars's atmosphere. So MAVEN will be orbiting through that interaction region and measuring how that process works.
So how would you describe the current Mars atmosphere?
Well, Mars is a cool place, but there's not much atmosphere. It's very cold. It's well below zero. The atmosphere is about 0.5% of what we're breathing here in this room. So it's a very different environment. But we know that Mars could change and was probably different in the past. There's a lot of evidence for flowing water on the surface from Mars's ancient history, and that's what we're interested in.
Well, scientists are tracking another event at Mars, except this object didn't come from Earth.
Yeah, this is Comet Siding Spring, named after the observatory in Australia where it was discovered. And in an amazing coincidence, just a few weeks after we get there tonight, this comet is going to fly right by the planet. So if you imagine the distance from the Earth to the Moon, imagine a comet going by 1/3 of the way from the Earth to the Moon. It's a unique event in the history of astronomy, and many places are gearing up to be able to watch this event.
Well, are there any risks to the spacecraft?
The estimates are that the risks to the spacecraft are very low. However, just to be safe, when the comet is going by, MAVEN will be in a part of its orbit on the other side of the planet, so it'll be shielded from the main flux of dust or small rocks.
Well, is there a scientific opportunity here?
Very much. This is a unique opportunity to see the atmosphere of the comet coming in at 56 kilometers per second and hitting the atmosphere of Mars. We'll be studying the comet and the effect on the atmosphere with the instruments on MAVEN, and many telescopes at the Earth will be looking at it, Hubble, Chandra, etc.
Well, John, we know you have a lot to pay attention to this evening, so thanks for taking time with us.
Thank you.
Every time we cut to the mission support area, we see a couple dozen people standing around staring intensely at computer screens. And as we've already seen, hundreds more have helped design and build MAVEN and its instruments, to say nothing of those that have worked on the logistics and the planning for such a big mission. Can't be overstated, teamwork is the ultimate tool for space travel. And that's why we've invited Lisa May, Mars Program Executive, to join us here on the set. Welcome, Lisa.
Thank you, Gary. It's a pleasure to be here tonight. It's very exciting.
It is, so far. Engines are burning. That's great.
Engines are burning.
NASA's something like a symphony conductor on a principal investigator-led mission like MAVEN. Is that right? Or?
You know, that's a pretty accurate description. Dr. Bruce Chakosky from the University of Colorado is the principal investigator, and he really does lead the project team. But beyond that, there are other layers of teamwork, such as those of us at NASA headquarters, and in fact, the United Launch Alliance and the Kennedy Space Center, who put MAVEN on this great trajectory to begin with.
Well, let's keep going on the list here. Tell us who are all of the main partners.
So the main partners, of course, University of Colorado, LASP, where we have the principal investigator, and they also provided a couple of instruments, and they're doing science operations. The Goddard Space Flight Center, NASA's center in Greenbelt, Maryland, has managed this project, and it's their first Mars mission. It's very exciting for that, as well as providing 2 instruments for the project as well. We also have the Space Science Lab at the University of California, Berkeley. Of course, Lockheed Martin, where we're broadcasting from tonight and where the mission support area is, who built the spacecraft and is operating it. And as I mentioned, United Launch Alliance and the Kennedy Space Center. Oh, and we can't forget JPL, that's giving us all this great navigation and trajectory information.
So MAVEN is a principal investigator-led mission. A little bit of a mouthful there, but what does that mean? I mean, are all NASA missions, do they follow that model?
No, actually they don't. We have a couple of different kinds of missions. Some are directed missions, and there are really large ones like Curiosity, but we also like to compete for broad ideas from the science community. Little known fact, we don't actually solicit missions. We actually go out and ask for science investigations. And so Dr. Joukowsky proposed to that, and that's how we get principal investigator-led missions.
So it's all about the science, truly about the science.
Oh, for us, it always is all about the science.
So I understand there's this huge university component to the MAVEN mission. Why is that important?
That's important for a number of reasons. The primary one, of course, is that the cutting-edge research is being done in the universities.
So academia, industry, government agencies, but they all kind of have different styles. I mean, how does this mix of characters integrate into a single successful endeavor?
Well, there are 2 answers to that. The first answer is every space project is a team with disparate institutions that are participating in the mission. So we kind of know how to do this. Yeah. But specific to MAVEN, this team has been particularly intentional about blending the management styles of all of the institutions that have been involved and ensuring that the teamwork is excellent.
Fantastic. I know you've got a lot to pay attention to as a Mars program executive, so thank you so much for taking just a few minutes and coming over here and joining us on set. So we do appreciate it, Lisa. Thank you.
Thank you, Gary.
Good night now.
Good night.
For those of you that just joined us, this is live coverage of as the MAVEN flight team prepares for the spacecraft's arrival at Mars. Checking in again on our simulation, we see the engines are still firing on the spacecraft as we get closer to the red planet. On this image, we'll see, right here, we'll see the actual change in velocity of the vehicle as it makes its orbit insertion burn. As we've learned a few minutes ago, this line will abruptly change its angle when the main engines cut off.
Now, if you've ever set out on a road trip, a long road trip, the expression goes that getting there is half the fun. Of course, these days with our ubiquitous internet-enabled devices and our GPS-powered maps, everything's just a click away to find your route. But not so with traveling to Mars. Now, we're assuming that most of you haven't ever traveled to another planet, so the first thing you need to understand when planning any interplanetary travel is that the most efficient route is almost never a straight line. Simply flying a straight line from Earth to Mars, it's not going to work. Here's how the MAVEN team charted their trip from Earth to the next planet over.
If you want to send a spacecraft from Earth to Mars, how would you get it there? You can't aim straight at the red planet because it's moving around the sun almost 13,000 miles per hour slower than the Earth. Instead, you'll have to wait for up to 26 months for the Earth and Mars to be in just the right spot in their orbits, then carefully aim at a moving target. In November 2013, the controllers of NASA's Mars Atmosphere and Volatile Evolution mission, or MAVEN, did just that, launching the Mars-bound orbiter from Cape Canaveral, Florida on an Atlas V rocket. After separating from the rocket and the Centaur upper stage, MAVEN unfolded its solar arrays, pointed them at the sun, and embarked on a 10-month cruise to Mars. The launch sent MAVEN arcing outward on a path called a transfer orbit, which will intersect with the orbit of Mars on September 21st, 2014. By starting its journey when the Earth was behind Mars, MAVEN has been taking advantage of our planet's greater speed to catch up to its target. When MAVEN arrives, it will not be automatically captured by Mars's gravity, but will instead need to perform an engine burn to change its velocity by over 2,700 miles per hour. Just before Mars orbit insertion, the spacecraft will turn its thrusters in the direction of travel. Then MAVEN will fire its engines for 33 minutes. The engine burn will slow MAVEN's velocity, allowing Mars's gravity to take over, and pulling the spacecraft into an elongated 35-hour orbit. In the following weeks, MAVEN will reduce its orbit to 4.5 hours. Then it will deploy its science instruments and begin collecting data. MAVEN's findings will reveal how Mars changed from a warm, wet planet early in its history to the cold, dry world we see today, shedding light on one of the solar system's biggest mysteries.
Tim Pryder, our Chief Systems Engineer for the MAVEN mission, and he's back with us again, so thanks for staying with us, Tim.
Sure.
So, how are we doing?
Nominal is good. There's no issues, no concerns. Spacecraft is traveling right down the corridor like we would hope and expect.
So we just saw in this last piece that a straight line is not metaphorically or even really mathematically the right way to get from Earth to Mars.
Well, that's correct. That George Jetson had the ability to zip from point to point, but it doesn't work. Everything is in orbit, or at least a part of an orbit. We're orbiting either Earth. During our transfer orbit to Mars, we're orbiting the Sun. Both Earth and Mars are also orbiting the Sun. So what we've done is gone from one orbit, Earth-centered, to a heliocentric orbit. And then right now, we are trying desperately to get into a Mars-centered orbit.
Wow, just kind of moving along through that planetary plane there. So,
Yep.
So, but is the spacecraft, is it flying autonomously by itself, or is it under the control of mission support? What's going on?
It is. The only control they've had is when they built the sequence weeks ago. So yeah, it's autonomous. The flight software is taking care of every command and every feedback loop and every control cycle.
So the data rate at this stage, high bandwidth, low bandwidth, how much data are we getting?
40 bits per second.
Wow.
Not just this side of useless. So what we need is something that's more, and the spacecraft team is using that very low data rate to confirm some of their expectations, but they're all riveted on the Doppler plot.
And that's strictly because the high gain's not pointing at Earth right now.
We can't point the high gain at the Earth because the GNC system is so busy keeping the thrust vector pointed to where it needs to be.
So let's talk about this Doppler plot. Let's get back to this. We see this green line trending a little bit. Tell us what's going on.
Right, so we're settling in. What this says to me is that we started off very, very nominal, but as the burn progresses, the very small uncertainties in the thruster performance and maybe the mass properties of the vehicle, if the CG isn't right down the middle of those thrust vectors, then there's going to be some buildup of some very small errors. And if you probably can't see the units on the side, but this is very, very tiny. As long as we stay in this corridor, everything is nominal.
So we've been saying this is mathematically what we predicted, but anywhere in this area, especially as we go over time, we're still really good.
Yes, the errors will accumulate. And then what happens when the engines cut off is all of that dynamic and those uncertainties of the performance of the engines and the offset of the CG, those go away, and we're back to just simple orbital mechanics. And there's uncertainties associated with that, but they're a lot smaller. So we will see, and if this trend continues, when the engines cut off, this Doppler signature is going to drop back down toward the middle.
So the main engine burn is clearly one of the big missions, big fuel expenditures. Once the main engine's burn comes to a completion, they're never going to be used again, right?
Well, that's not true. They have one more use in their quiver, so to speak, right? We tested them once right after launch to make sure that they were going to work the way we expected them.
Okay.
Obviously, they're doing the main event tonight. And then once we capture into our 35-hour orbit, we will use them one more time to reduce that orbit period from 35 hours down to about 5.5. And then we rely on the smaller thrusters to take it down to the 4.5.
And so what about those small thrusters? I mean, what are they used for? Primarily like steering, keeping that attitude?
Yeah, so we have attitude control, the slews. We have to do orbit maintenance during the science life.
Point to us where these attitude thrusters are.
Well, so the main engines are the big cluster in the middle, and then the attitude control thrusters are the ones on the periphery.
Okay, so how long, if after tonight's burn, I mean, how much fuel is going to be left for this mission?
The expectation, tonight's burn is very deterministic. We'll use 250 gallons of fuel. We launched with 425. So it's a big majority. But after tonight, we should have about 170 gallons left. And then that transition phase where we resize the orbit from the 35 hours down to the science orbit will take about 80 of that. So that leaves us with 90 gallons of fuel. We've budgeted 50 for that 1 year of science, so we have plenty.
Good deal. Well, looking at the time, we're starting to get a little bit closer. Thanks for the update, Jim.
You're welcome.
We'll check back in just a few minutes.
With the MAVEN spacecraft just now reaching Mars, it's easy to think that NASA and its partners simply unwrapped a new space vehicle and sent it on its way. Nothing could be further from the truth. Every time humanity sends a probe out into space, that vehicle has to be carefully designed and constructed, piece by piece. Now, that doesn't mean every spacecraft starts from absolute scratch, however. There are a variety of commonly used parts and designs that can be the basis of each new vehicle. But by and large, every spacecraft is handcrafted. MAVEN's design is a direct result of focused collaboration among all of its partners. Science goals drove design, and then form followed function. 2 instruments were built at the NASA Goddard Space Flight Center in Greenbelt, Maryland, 4 at the University of California at Berkeley, and 2 at the Laboratory for Atmospheric and Space Physics at the University of Colorado. Lockheed Martin Space Systems was involved from the earliest stages of the project and had the role of the spacecraft's design, not to mention being the place where the vehicle came together. Here are a few behind-the-scene images of the spacecraft and the engineering team as it was all coming together in a clean room adjacent to where we're standing right now. Design, construction, launch, and operation are all developed to ultimately deliver high-performance scientific instruments to Mars, to make measurements and to help scientists do research. Joining us again is John Clark to explain what those instruments are and how they're going to be used.
Hi, Nancy.
You know, so John, this isn't the first vehicle NASA sent to orbit Mars. In terms of technology, what makes MAVEN different from earlier orbiters?
Well, MAVEN was designed specifically to measure the atmosphere of Mars, the solar wind hitting the atmosphere of Mars, and the loss of gases into space. In addition, the orbit of MAVEN around Mars was designed to dip low into the atmosphere and then rise high up to sample the different regimes.
Well, here we have a scale model of the actual spacecraft currently en route to Mars. Please show us around.
Okay, I'll start with just the main systems. This is the high-gain antenna that Tim talked about, still has a cover on there. The body of the spacecraft, the solar panels. MAVEN is 100% solar power. And you have 2 antennas that go off here to detect plasma waves. Around the corners of the body of the spacecraft are most of the instruments to measure charged particles in the solar wind, ions and electrons. And this little boom coming off here is the articulated pointing platform, or app. And that has an ultraviolet remote sensing instrument, a mass spectrometer, and the low energy plasma instrument.
So MAVEN doesn't have pictures, but so we could call the data that we get measurements, correct?
I think that's a good way to go. Right. Yeah.
Well, earlier we heard about one of the mission's biggest goals is to understand what happened to the Martian atmosphere and thus how Mars went from a wet to a dry planet. Explain what systems the team will be using to understand these processes.
Right. So we think that, we're interested in the history of water on Mars, and there are only two places water could go. It could boil off into space or freeze onto the surface like a permafrost on the Earth. So MAVEN is to study the detailed processes by which the atmosphere escapes into space today. And if we understand what controls that escape, we can then move back in time and estimate what happened before.
Well, thank you, John. Thanks again for stopping by.
My pleasure.
So over the many years of design, development, planning, and construction, hundreds of people have dreamt about getting this huge mission into not only into space, but successfully into operations around Mars. Big projects can only result from big efforts and deep wells of passion and commitment. Let's hear some thoughts from those who have given a big part of their past few years to make the MAVEN mission a reality.
My name is Bruce Jakosky. I'm the principal investigator on the MAVEN mission, which means that I'm responsible for the implementation of the entire mission and getting the science results out of it. MAVEN is the Mars Atmosphere and Volatile Evolution mission. Our goal is to study the role that loss to space has played in the history of the atmosphere. At its peak, we've had about 500 or 600 people working on the project. That's difficult in itself because the team is distributed around the country.
Well, an important part of the MAVEN mission is getting all the teams working together. We have partnerships spread across the country, starting with University of Colorado LASP, with Lockheed Martin in Denver, University of California at Berkeley, with the Jet Propulsion Lab in Pasadena, of course Goddard Space Flight Center. What excites me about MAVEN is just the collaboration. It's been a tremendous experience to be working for a common goal.
Todas las misiones necesitan cientos de individuales. No es de una o dos o tres personas que hacen una misión, son cientos de individuales que se necesitan para hacer el trabajo y no es el trabajo de una persona o de dos, es de cientos de personas.
MAVEN is very exciting to me. I've actually had the privilege of working on the last 3 Mars orbiters that NASA has sent to Mars. Some of the aspects of how we're actually going to control the spacecraft are really going to build off of the techniques that we've used on those past missions.
I think that exploration is just exciting. It is extremely cool that we're going to Mars. MAVEN is going to be looking at the atmosphere to understand what's changed and what is going to change. And it has implications for our future travels to Mars, and it also has implications for us back on Earth.
Well, MAVEN is a really exciting mission to me. I've been involved in Mars research now for 15 years, but I've never been involved in a mission like MAVEN that has the full suite of instruments. It's a wonderful opportunity to really get at some of those questions that have been in my mind now for years, and now we'll finally have the tools to answer them.
A lot of us engineers, when we were kids, that's what we dreamed about, right? Going to other planets. So this really is kind of at the forefront of exploration. One thing exciting about MAVEN is we've done a lot of missions staring at the surface, but now we're going to look at the atmosphere of Mars, and every time we go to Mars, we discover something new.
MAVEN is the next logical step in the progression of understanding Mars. It really addresses questions that are fundamental to Mars and to the ability of the planet to support life. Everything we see is going to be a first-time measurement and a fundamental discovery.
Wow, the voices from the MAVEN team, you could just feel the passion there. I mean, there's clearly a lot of excitement here, as well as around the country. In just a few minutes, we're expected to hear confirmation that the engines are shut down like they're supposed to. But this makes it a perfect time for us to take a short break, check in with a few questions from the interested Mars watchers around the country.
And when we come back, the team should be just minutes away from arriving in their initial Mars orbit. Also, we'll hear from NASA senior staff on their thoughts about the mission, and we'll continue to keep our eyes on the mission support area for the latest updates.
You're watching coverage, live coverage that is, of the interplanetary spacecraft called MAVEN as it arrives at Mars tonight. Only on NASA TV. you go.
If you're just joining us, this is specialized coverage of the MAVEN spacecraft's arrival at our planetary neighbor Mars. I'm Nancy Jones from the NASA Goddard Space Flight Center.
And I'm Gary Napier with Lockheed Martin, and we're again joined by MAVEN Spacecraft Chief Systems Engineer Tim Preiser. The MAVEN spacecraft's been traveling for just over 10 months to Mars, and if you've been with us for the past hour, you know it's on its final approach. Propulsion systems have been firing for a little over a half an hour, and any minute now we should be hearing word that those engines have cut off. So Tim, tell us how everything's looking to you.
Everything looks fantastic. You know, MAVEN has performed flawlessly since she launched, and she continues to do that today.
Let's just see if we can listen into the flight controllers and see if there's any chatter on the net.
They're probably is anxiously watching that Doppler plot.
Quiet's good though,
like
right?
We are. Quiet is great.
So there's a lot for the team to track at this stage, from the engine performance to navigation data to the overall health of the vehicle, but there's not a lot they can do right now in these last final minutes, right?
Yeah, they can spectate along with the rest of us and watch with confidence as MAVEN performs her duty.
Okay. You and I were talking earlier about what this plot meant and the fact that it's been tracking a little bit. Bring our viewers up to speed.
Right, so the residuals that we're measuring here are, one, very minor, but two, is showing that all of our engines and our center of gravity may have been off by just a little bit. So we have been what I would characterize as a little bit underperforming relative to the predictions. So as we watch this current time go across this plot, we have a band in here where we expected the engines to cut off. And right in the middle would have been the nominal. So we'll see how close she comes to the pin.
So we think we're going to run just a little long beyond that 33 minutes?
Yeah, simple integration would tell me. If we're underperforming just a bit, then yes, it'll take us just a few more seconds to get there.
So we clearly have just passed that time mark that was predicted.
So this minimum time was what we needed to actually capture. So at this point, we feel pretty confident that we've crossed that line in the sand. The line on the other side is one that would tell us we have burned plenty and we don't want to get any closer at our closest approach. So somewhere in between here, and nominally it should be in the middle, or actually closer to maybe the first one, is where it would have cut off if everything was right down the pipe. Okay, so you can see there is a bit of a residual there. So now we have to integrate our way through there. But as I can see, there are now 3 Doppler measurements that have just changed dramatically from this trend. So
what does that mean?
That means, to me, the engines have been commanded to turn off.
Okay. So the engine may have turned off. Let's know if we can go.
This is MAVEN Nav on MAVEN Cord. Based on observed navigation data, congratulations. MAVEN is now in Mars orbit.
Fantastic.
Wow, okay. My goodness.
Oh my goodness.
Awesome.
Wow, that just came, you called it. You called it. There it is.
Data doesn't lie.
Now, who was that was just on the net?
That was Dave Folta from Goddard Space Flight Center. He is our chief navigator and has actually been the one that has been calming us as we approached Mars. When it was just a little baseball and now it was a big baseball, he had it all under control.
This is an exciting time. I mean, what are you feeling right now?
I'm about to pop. It's a blender of pride and relief. I can't tell you how proud I am of the little spacecraft and certainly of all the people that worked on her. It's been a long, long journey by a lot of people to get to this point today.
Fantastic. Thank you so much. I think are we going to be able to just let's listen in on and watch the MSA for just a little bit.
Congratulations, Dave.
So we can have that live segment. Now we're going
While
back to
all
calling.
eyes are on activities one planet over, it's good to remember that such a sophisticated mission requires lots of people back here on Earth with tons of foresight. NASA's Goddard Space Flight Center had a big hand in keeping the ship on course, And joining me now is Colleen Hartman, Deputy Director for Science at the Goddard Space Flight Center. Hello, Colleen.
Hi, how are you doing?
It's a big night. How are you feeling?
It's great. I don't have any fingernails anymore, but we've made it.
All right. That is so exciting.
It's incredible.
Now, Goddard is a world leader in studying the Earth from space to the sun, and with the Hubble Space Telescope, also looking out into the cosmos. Now Goddard is managing its first Mars mission. Tell us about that.
Well, Goddard has been a leader in managing many missions in the planets. In fact, we are the Lunar Reconnaissance Orbiter mission manager, and it's currently in its 5th year of mapping the moon. We're getting petabits of data back all the time. Back in the 60s, we did Earth observing missions, including Aqua and Terra. We built Landsat 8 that just launched recently for Ball, with Ball and the USGS, U.S. Geological Society. We have ISAT-1 working, mapping the ice of the Earth. So Goddard has had a leading role for many, many decades, and our partners are strong. We're here at Lockheed Martin. They helped us build the Hubble Space Telescope that you mentioned, still the iconic spacecraft in the skies. And right now they're helping us build OSIRIS-REx, which is another mission managed by Goddard, and it will go to a near-Earth asteroid that's named Bennu and actually return a sample to Earth. So we have a long history of managing planetary missions, and in fact, every mission to a planet has had a Goddard instrument on it, and I'm really proud of that.
Well, yeah, I mean, you mentioned that. So, give us a little background, a little bit more insight into, all the instruments and where they've gone. Just give a little bit more insight on that.
Well, you can go way back because Mariner, the Mariner series in the 60s and 70s, it had a Goddard-built infrared sensor on it that went to Mars. So it's sort of what goes around comes around.
That's right.
Yeah, so this infrared sensor, it looked at the temperature of Mars, it looked at the CO2 content on Mars, and it just shows that as we gain technology and the entire world looks toward Mars, we're learning more and more. So Voyager had an infrared spectrometer and a magnetometer, all built by Goddard. The Galileo probe, the probe that went in, it actually had a Goddard instrument on it as well. Mass spectrometers have gone to Jupiter, built by Goddard. So I'm very proud to represent Goddard here and be a member of a team in the United States, but even more than that, a global team.
Well, Colleen, thank you for joining us tonight. I know you're just head over heels, so thank you.
Hurrah,
Congratulations.
MAVEN. Thanks.
Ever since MAVEN got into orbit, or just I should say prior to orbit, things have been pretty quiet here in the MSA, and things have been pretty tense, quiet. The moment they declared defaulted that it went into orbit, it's been loud as can be around that corner. I can still hear folks cheering and patting each other on the back. So it's been a fantastic night. A very integrated team from all of the institutions, whether it's CU, NASA Goddard, Lockheed Martin, the Jet Propulsion Laboratory. These folks have done just an amazing job. Extremely excited for them. Let's just take a listen in for a little bit longer.
We coming, Pete? All right. Come on now. We need to
MAVEN marks a major milestone for NASA, as well as the whole science community affiliated with the planetary initiatives. But more specifically, the space agency has made Mars a major target of its overall interplanetary research efforts. Senior agency staff have been watching tonight's events adjacent to the mission support area too, of course eagerly awaiting word of MAVEN's arrival. Joining us now is astronaut and now Associate Administrator for Science, Dr. John Grunsfeld. Thanks for taking a few moments with us.
Oh, it's my pleasure. This is such an incredible night.
I know. Well, you saw it just like we did. What do you think? What are you feeling?
Well, first of all, it's so incredible that we can do these things at all. I mean, here's a spacecraft hurtling towards Mars, for which we have no control over it, because it took over 12 minutes for the signals to get to us. The event had actually happened, and we were just waiting to find out. And it's just amazing that we have such the opportunity to build a spacecraft like MAVEN to learn about the mysteries of Mars, and that it all worked like clockwork.
Well, you know, MAVEN is just one asset at Mars. And so just tell us a little bit more about NASA's journey to Mars. Explain to us, you know, what the Mars Initiative is all about.
Well, our journey to Mars is a worldwide issue, not just what NASA is doing, but what we're doing in cooperation with our international partners. And of course, close on the heels of MAVEN is the MAVEN mission from India. But we have our Mars Reconnaissance Orbiter and Odyssey orbiting Mars now, joined by MAVEN, very exciting. And on the surface, we still have the Opportunity rover and the Curiosity rover. And Curiosity has just made it to start its climb of Mount Sharp on Mars and try and answer the question of, you know, what happened to Mars' atmosphere. At the same time, MAVEN has made it to Mars orbit to tell us the same thing. So this is going to be phenomenal.
Well, you talked a little bit about the current missions currently at Mars. So what's coming up? What's next on the horizon?
Well, of course, all of these missions, the robotic missions, are human missions because they don't discover anything at Mars. People on Earth discover things, scientists and astrobiologists. So I'm really excited about NASA trying to reach forward and eventually send people around Mars and to the surface of the Mars. And to prepare for that, we have a lot more in store for us. In 2016, we have the InSight lander. It's going to land on Mars and put a seismograph geophysical station on the surface. 2016 and 18, we're partners. The European Space Agency is leading with their ExoMars program, an orbiter and lander. And then very exciting in 2020, we're going to put another rover on the surface, even more capable than Curiosity. And what's special about that is that it has a system to put samples that we may someday get back from Mars, the first sample return. But more importantly, it also has an experiment on board to produce oxygen from carbon dioxide in the Mars atmosphere. And this is a precursor to human space flights to show that we can live off the land on Mars once we get human planetary scientists and astrobiologists on Mars.
Well, the really exciting stuff coming up. Thank you for taking time with us
Oh, my
this
pleasure.
evening.
Just an exciting evening.
Yes, congratulations.
Thank you.
In some cases, there's a case for studying Mars as much as there is, say, for climbing mountains on Earth. But NASA's reasons for such explorations clearly extend beyond romantic ideals. The old expression, because it's there, just isn't quite enough. But NASA's more serious reasons most certainly are. There's a big picture behind NASA's multi-mission commitment to the Red Planet. Let's take a closer look at NASA's long-term Mars exploration motivations and plans.
Mars, a rich destination for scientific discovery. As we expand our presence into the solar system with robotic and human exploration, the formation and evolution of Mars will help us learn more about our own planet's history and future. In its past, the Red Planet had conditions suitable for life, and future exploration may uncover evidence of life, answering one of the fundamental mysteries of humanity. Does life exist beyond Earth?
At NASA, we're reaching for new heights so that we remain the world's leader in space. We're pioneers, and we always have been, and we're building on that pioneering spirit in science and technology so that we make the world a better place and we create jobs right here on Earth.
NASA is developing the capabilities needed to send humans to an asteroid by 2025 and to Mars in the 2030s.
We're building something that can go lunar, we can build something to go to an asteroid, we can go to Mars with this. This is the next step that we've been looking for since the Apollo era.
Robotic explorers have studied Mars for more than 40 years. NASA's path for human exploration of Mars begins in low Earth orbit aboard the International Space Station. On board the orbiting laboratory, astronauts are helping us prove many of the technologies and communications systems needed for human missions into deep space.
Well, the crews right now on the International Space Station are using this wonderful outpost to help us get farther and farther into space, to asteroids, to Mars, you mentioned. I think the science on station is making incredible breakthroughs that are going to help us make life better for people right here on Earth.
We and our other international partner crewmates are working off the planet for the planet.
NASA, along with our international partners, conducts scientific research every day here on the station as we use this orbiting laboratory as a stepping stone for future deep space exploration.
In tandem with space station research, NASA will send a robotic mission to capture and redirect an asteroid to orbit the moon. Astronauts aboard NASA's Orion spacecraft will explore the asteroid and return to Earth with samples. This experience will help NASA test new systems and capabilities, such as solar electric propulsion, which will send cargo as part of human missions to Mars. NASA's new Space Launch System will enable these proving ground missions to test new capabilities. Human missions to Mars will rely on Orion and an evolved version of the SLS, which will be the most powerful rocket ever flown.
With Orion and our heavy lift space launch system, we're going to send humans into space farther than they've ever gone before. This year's Orion test flight will be the most aggressive for a human spacecraft in more than 40 years.
Apollo happened before I was born, so this for our generation will be the exploration missions that we get to see in our lifetime.
A fleet of robotic spacecraft and rovers are already on and around Mars, dramatically increasing our knowledge about the red planet and paving the way for future human explorers. Future missions seeking signs of past life will demonstrate new technologies that could help astronauts survive on Mars.
I think some of the most amazing things that we're learning are actually how to be really good detectives on another planet, which is a really difficult job.
Engineers and scientists around the country are working hard to develop the technologies astronauts will use to one day live and work on Mars, and then safely return home from the next giant leap for humanity.
Through advanced aerospace technologies used in everything from modern aircraft to suborbital rockets and the commercial vehicles servicing low Earth orbit today, we're building the machines to take us farther into the high frontier. NASA is here to raise the bar for human achievement. We're a community dedicated to research and discovery in service to society. We have a responsibility to the future generations, to the future generations of engineers, scientists, technologists, explorers. That's our challenge.
Now that we have confirmation that the spacecraft is in orbit, let's take a brief look at what happens next. The initial orbital path around Mars is designed for the planet's gravity to simply capture MAVEN. Shortly thereafter, flight engineers will begin refining the flight path, placing the spacecraft in a specific orbit to begin gathering scientific data. Remember, the spacecraft will be in an elliptical or egg-shaped orbit, making close passes to Mars on one side of its orbits and distant high overhead passes on the other side, all designed to get different views and measurements of the Martian upper atmosphere. In a couple of weeks, the spacecraft team will deploy its instruments. The team will start running tests to make sure that everything is working like it's supposed to be working. And then, after a short medical exam, if you will, MAVEN will go into gathering data and relaying it home.
138 million miles from home, our nation's newest robotic agent is on the case. For engineering and scientific teams from the University of Colorado, from NASA, from the folks here at Lockheed Martin, the University of California, Berkeley, the Jet Propulsion Laboratory, and the loyal fans around the world, tonight marks a major moment forward for planetary science and exploration.
The Mars Atmospheric and Volatile Evolution mission, MAVEN, is now in orbit around our sibling planet Mars after a 10-month journey. Gary, I don't think I'm overstating the case when I say there are a lot of people in this building and at other facilities around the country whose pulse rates are just now starting to come down.
Mine's not coming down. This is awesome. I mean, Nancy, I totally agree. But as exciting as it is, in many ways, the mission is really, it's just beginning tonight. Because now that MAVEN's arrived, the important work of figuring out what happened to the Martian atmosphere and why can finally get underway.
NASA is committed to pushing the boundaries of human knowledge. By looking out into the solar system and beyond, we discover essential things about our own place in the universe. With tonight's Mars arrival, MAVEN continues that commitment.
You can learn more about the mission and follow the progress of the teams and research at the official website, www.nasa.gov/MAVEN. Also, coming up in just a little over an hour right here on NASA TV, we'll have a live press conference with MAVEN senior staff to discuss the status of the spacecraft and the mission after tonight's historic arrival. And I think you're going to want to listen because it's going to be good news.
That's right.
Now, that's midnight on the East Coast, 10 p.m. here Mountain Time. So hopefully you can stay up just a little bit longer and tune back in.
It's not often that the people of Earth send a probe to another planet. We did that tonight. And we're glad you could join us here at NASA TV to experience it live.
From all of us here at Lockheed Martin in the Mission Support Area in Littleton, Colorado, thanks for tuning in.
And from the NASA MAVEN project team managed at the Goddard Space Flight Center, we also thank you. Good night, everyone.
Good night.